Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Positional isomers arise when substituents can occupy different positions on a benzene ring. For dichloronitrobenzene, the molecule has 3 substituents on benzene, 2 Cl atoms and 1 number 2 group, total 3 substituents on a 6-membered ring. Moving on to the next step. Fix the number 2 group and determine the possible positions of the 2 Cl atoms relative to number 2. Moving on to the next step. With number 2 fixed at position 1, the 2 Cl atoms can be placed at various combinations of the remaining positions 2, 3, 4, 5, 6. Using symmetry of benzene, unique positions for 2 Cl atoms relative to number 2 at C1. Cl at 2, 3, both ortho meta. Cl at 2, 4, ortho and para. Cl at 2, 5, both ortho positions on opposite sides. Cl at 2, 6, both ortho, symmetric. Cl at 3, 4, meta and para adjacent. Cl at 3, 5, both meta. And for the final step, count unique isomers by considering mirror symmetry. 1, 1, no 2, 2, 3, DCl. 2, 1, no 2, 2, 4, DCl. 3, 1, no 2, 2, 5, DCl. 4, 1, no 2, 2, 6, DCl. 5, 1, no 2, 3, 4, DCl. 6, 1, no 2, 3, 5, DCl. All 6 are distinct structures. 2, 6, DCl is symmetric, Cl on both ortho positions, so it is one unique isomer. Total is equal to 6 isomers. Why other options fail? A. 3, too few, ignores many positional combinations. B. 4, undercounts, misses some unique arrangements. D. 8, overcounts, does not account for benzene ring symmetry properly. Therefore, the correct answer is C. Therefore, the correct answer is option C.